So welcome again for the embedded machine learning course on a Coursera platform. It's a week two, and the exercise for the neural networks and training. So we will go to step by step and see if our answer passed to the question to the exam. And the first question is the activation function allows a node or a perceptron. So activation function allows a node what to act as a linear regression function. So let us first see what is the possibility to allow a activation function for the node. First of all, we have to go to the um, all questions. Okay. Okay, so yeah, the first answer for this one is obviously false because activation function is not allowing to do anything to the knot. It will just cut off some of the numbers if it fulfills the condition for the node or not. So we will go for the false. The second question is a single node in a neural network performs the following actions in order. Okay, so first it multiplies each input value by a weight. Yes, it's true. Then it sum of the products of a step 1. Yeah, it's also true. It's a bias term to the sum computed in a 2. Yes, it's also true. And then applies a activation function to sum from a step 3 to produce a single value output. Yes, so that is the procedure here. um, I can show you it with some yeah, some um, whiteboard, so you can see the whiteboard or not. I first have to go to the scene 2. Yeah, now you can see the whiteboard. And here I can go with for a step by step procedure. So the first step was multiply each input values by a weight. So if if the okay, wait a second. Okay, so how it is going to do this? um, so let us say if there is one node here. So node is having like theta 1, theta 2, and theta 3. And if there is a 3 input x1, x2, x3, and one another by default value x3. So what first it will do is to create an hypothesis, for example theta 0, but it is not always true. So we will just erase it out. X0 plus x1 theta 1 plus x2 theta 2 plus x3 theta 3. So first this node, so this is a node. Okay, and what it will do. Okay, so first you have to do. Okay, now so what it will do is first multiply um, every input. This is an input uh, with this one. So um, yeah, the first step is already done. The second is a sum of all the products. I have already told you that is it is a sum of every product. So uh, Yeah, here you can see the sum, and yeah, it's the step 2. This one is a step uh, 1, and this is a step 2. And then what is supposed to do is add a bias term to the sum computed in a step 2. So what is the bias term? So bias term is a result. So um, this whole term from here to here will be deducted from bias term with, let us say, bias term is a y, and now you got a result of this all, and you get here some value. Now check the value if it is less than or greater than or equal to some value, let us say a, and then decided if for example v is less than a, the node uh, will give, this node will give output as a 0. If this v is equal to or greater than a, this node will give output as a 1. So this is the whole procedure. Now we can go for the question here. So is this procedure is true or false? So we can just go for the true option. Now back proportion is the process of computing prediction. uh, Back proportion is a process of computing prediction given an input parameter sample and comparing the model's prediction to the sample's non-label to the calculate value. So it's just a false. I will not go down into the deep to save the time. Now model parameters, that is the weight in a bias term. So I already have told you what is the weight in a bias term. Let's just take a look for the weight in the bias term. So here you can find the weight in the bias term, but okay, let's make it a small one for you. Okay, so what is the main uh, source here? Okay, now you can get these things right, and I'll just put out the eraser on that. It's not for me. Okay, now so first we will see what is the weights and what is the bias. So uh, in the matrix, theta 0, theta 1, theta 2, theta 3, and so on. So this is called the weights. mm, X uh, 0, x1, x2, x3, and so on of transpose. Okay, let us see this transpose, and this one, um, and here you can get a y. Okay, so just take it is a one value y. So yeah, here you can see that here capital theta 2 into x is equal to y. So theta is a weight, x is a features, and y is an output. Sorry, not good put, it is an output. So the question is here that if the model parameter, the weight and terms are updated automatically by the programmer during the training. So it is not updated actually automatically. um, because the bias term here, that is actually the y. mm, you can see y we can say is a bias also, so output is bias, and this y is always a static, so you cannot change the bias but just the weight, so we can go for false. So performing forward and backward process to the model, the entire data set is called what? It is called an epoch. Yeah, that's all. So we can just yeah, so now you can see that I mm, pass with 100%, you and you also can pass with 100% obviously. So yeah, that's all for the today's video, and we will see in the next exam. So this exam is for neural network and training for week 2.